This problem is from 2009's AP Calculus AB free response problem number 2. The problem is, the rate at which people enter an auditorium for a rock concert is modeled by the function r given by r of t is equal to 1380 t squared minus 675 t cubed for t is less than or equal to 2 and greater than or equal to 0 hours, while the function r of t is measured in people per hour. No one is in the auditorium at time t equals 0 when the doors open, and the doors close and the concert begins at time t equals 2. Part A. How many people are in the auditorium when the concert begins? We know the concert begins when the doors close at time t equals 2, and we know that people start entering at time t equals 0. We also know that the rate at which people enter is r of t, which is given, so we can evaluate the integral from 0 to 2 of r of t, and it's dt because the function is in terms of time t. And we can either solve this by hand or plug into a graphing calculator to get an answer of 980 people are in the auditorium when the concert begins. Part B. Find the time when the rate at which people enter the auditorium is the maximum. Justify your answer. We know that for the rate at which people enter the auditorium is a maximum, then either the derivative of the rate, or r prime of t equals 0, or it is at an endpoint of r of t, and we know the endpoints are at time t equals 0 and 2 because those are the endpoints of the time frame we are given. So first we can solve for r prime of t, which is 2760t minus 2025t squared, and when this is equal to 0, t is either 0 or roughly 1.36296. And again, we also have the endpoints 0 and 2, but since 0 is only accounted for, we only have to add a third point, which is t equals 2. So then we evaluate r of t at each of these points and get r of 0 is equal to 0, r of 1.36296 is roughly equal to 854.527, and r of 2 is equal to 120. Now from these three outputs, we can clearly see that r is greatest when t is equal to 1.36296, so the rate at which people enter the auditorium, or r of t, is a maximum when t is roughly equal to 1.363, which is rounded to 3 decimal points since on the AP test we round to the nearest thousandth place. Part C. The total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function w models the total wait time for all the people who enter the auditorium before time t. The derivative of w is given by w prime of t is equal to the quantity 2 minus t times r of t. Find w of 2 minus w of 1, which is the total wait time for those who enter the auditorium after time t equals 1. We know from the fundamental theorem of calculus part 1, which I covered in a previous lesson, that w of 2 minus w of 1 is equal to the integral from 1 to 2 of the derivative of w, which is w prime of t dt, because this is in terms of time t. Now we are given w prime of t, which is the quantity 2 minus t times r of t, which we can just plug into the integral, and then we can expand the product 2 minus t times r of t, since we are given r of t, and get the integral from 1 to 2 of 675 t to the fourth minus 2730 t cubed plus 2760 t squared dt. Now we can plug this into a graphing calculator and we get our answer of 387.5 hours, which is the total wait time for people who entered the auditorium after time t equals 1. Part D. On average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open, and use the model for total wait time from Part C. If we go back to Part C, we can see that the model for total wait time is the integral between the two time endpoints of w prime of t, which we know is 2 minus t times r of t dt. So we can use that, but instead of the integral from 1 to 2, we can use the integral from 0 to 2. And of course, we still know w prime of t because we solved it in part C. And then we know that we can plug this into a graphing calculator to get that the total wait time was 760 hours. However, the question is asking for the average wait time per person. From part A, we know that there are 980 people total, and if those people waited 760 hours total, and there are 980 people, we can divide the total time by the amount of people to get an answer of 760 over 980, or roughly 0.776 hours per person. This has been 2009's AP Calculus AB free response question number 2, and I hope that was helpful.